Okay, so what we're going to talk about is CO2 transport. Now, conceptually, remember, this is the path, how CO2 is transported. So we've got tissues, right? From tissues, it goes into the blood, and goes into the lungs, and then you exhale. Now, let's take a look at this whole process. So this is going to be a gigantic red blood cell. Now, we were just talking about it. Listen up. Which molecule transports oxygen? We just talked about it. Which molecule? Which protein? Take a look. Which protein transports oxygen? Yeah, this is hemoglobin. Now, it means, listen, it's very important. We're just going to remember that there's a lot of hemoglobin in red blood cell. We clear? Now, what's outside red blood cell? Outside red blood cell is plasma. And the main protein in plasma is albumin. Okay, does that make sense? We're going to give it a name, Al. Just. Okay, so albumin is in plasma, while hemoglobin is in the red blood cell. So it all starts with the CO2. Okay. Being in the tissue. So CO2 from the tissue diffuses into blood. Okay? So in the blood there are two options for CO2. Option number one just stays dissolved. CO2 is pretty well dissolved in the blood. It's like 7% of all CO2 is just dissolved in the blood. Does that make sense? Some of the CO2 that goes into the blood. Remember, this CO2 is still in the plasma. What happens is this. CO2 interacts with water. Okay? This results in the production of bicarbonate anion and hydrogen ion. Does that make sense? Hydrogen ion binds to albumin and forms this complex. Now, why this is important? Look, binding of hydrogen to albumin shifts this equilibrium this way. Are you following me? So removing hydrogen from equation constantly shifts the equilibrium to the right, promoting the reaction between carbon dioxide and water. Bicarbonate here forms bicarbonate buffer system, which we're going to talk about in the next chapter. So far we good? The majority of CO2, and this is important, so that's about 7%. Okay? This is about, I think, 15%. So I don't remember the exact percentage, but the majority of CO2 actually, look, diffuses into the red blood cell. So one option for CO2 is to bind to hemoglobin directly. Now, what's important is that CO2 doesn't compete with oxygen. Am I clear? So CO2 forms a complex with hemoglobin with its protein component. Am I clear? It just binds to protein part of hemoglobin molecule. And this is called carbaminohemoglobin. But the overwhelming majority, now look at this. Look, this is kind of cool. Overwhelming majority of CO2 takes a different route. It interacts with water inside the red blood cell, producing bicarbonate and hydrogen ion. Does that make sense? Now, what happens to hydrogen ion in plasma? In plasma, this hydrogen ion binds to albumin, right? Which is the most abundant protein in plasma. Are you following me? What happens to hydrogen ion in red blood cell? The most abundant protein there is hemoglobin. Are you following me? So instead of albumin, hydrogen ion will bind to hemoglobin, resulting in the complex between hemoglobin and hydrogen ion. And that shifts equilibrium to the right. Does that make sense? Are we clear? Well, there are a few things that turn out to be very fascinating. Look at this. When this process happens, you see it's a tissue and blood, right? Carbon dioxide goes from tissue into the blood. Am I clear? Now oxygen, look at this. Oxygen goes from blood, from red blood cells, to tissue. Are you following me? Turns out, when hydrogen ion binds to hemoglobin, it kind of kicks out oxygen. It makes oxygen unloading much more effective. Are you following me here? Now, look what happens. Imagine that your tissue is very metabolically active. It actively uses oxygen and produces a lot of CO2. Are you with me? The more CO2 you have, the more intense this reaction is going to be. That makes sense? More CO2 means more hydrogen ions. Are you following? More hydrogen ions means that there will be more oxygens kicked out of hemoglobin. We good so far? No?
That last part kind of confused me. Like, I get where, like, the C2 goes to the CO2 plus HO2 because it's up there, and then that second part's up there. But then that third part,
This one?
yeah, that's...
I'm just continuing. So this hydrogen ion, this hydrogen, okay? This same hydrogen will bind to hemoglobin afterwards. So it is produced first, and then it binds to hemoglobin. Are you following me? When it binds to hemoglobin, it kicks oxygen out. I don't put it on the board, but believe me, that's true. Are you with me? So essentially, if you have more CO2, you have more hydrogen ions. If you have more hydrogen ions, they kick out more oxygen. Does that make sense? Which means more oxygen will go to metabolically active tissue. You see? So this is called the Haldane effect. So again, kind of generally, this part here is the main route for the transport of CO2 in the blood. So let's summarize what's going on one more time. You can look at your records and just kind of match them. Good so far? Keep it up? So carbon dioxide, after it diffuses into the blood, it can stay dissolved in the blood. It can interact with water in the plasma. This interaction will produce carbonic acid. Well, I kind of missed the step here. Input. Will produce carbonic acid, which will dissociate into bicarbonate and hydrogen will bind to albumin. Does that make sense so far?
Yeah.
And it diffuses into the red blood cells, where it either can bind directly to the protein component of the hemoglobin, forming carbaminohemoglobin, or CO2 can interact with water, producing carbonic acid, H2CO3, which then will dissociate into bicarbonate and hydrogen. And inside of the red blood cell, hydrogen ion will bind to hemoglobin, instead of albumin, bind to hemoglobin, increasing oxygen unloading. So far, we clear?
You have like a HCO3 and then minus and then a plus.
I don't understand
Is
the
that-
question.
Oh, I'm like, yeah.
Here?
Right there. It
Yeah.
has to be like plus. H.
No, H plus, it's positively charged. HCO3 minus is negatively charged.
Why are there two pluses?
Huh? Is it better? Okay. Good? So this is the way, carbon dioxide transport works.